Welcome to competitive versus non-competitive inhibition. Before we dive into the mechanisms of each, let's first introduce the key components. This is an enzyme. An enzyme is a protein that catalyzes reactions by lowering the activation energy. The activation energy is the maximum amount of energy required for a reaction to produce products. An enzyme is not consumed by the reaction and it produces products at a faster rate. It also recognizes certain substrates and then proceeds to bind to them. A substrate binds to the enzyme to produce products. It binds specifically to the active site of the enzyme, which is complementary in shape, and are also known as reactants. Now that we understand the first two key components, let's look at the mechanism. The substrate binds to the active site of an enzyme, releasing energy to produce products. We also want to understand the different sites of an enzyme that both substrates or inhibitors can bind to. An active site is where the substrate binds to the enzyme. It is used specifically in competitive inhibition. An allosteric site, on the other hand, is introduced for non-competitive inhibition and is where the inhibitor binds during non-competitive inhibition. A competitive inhibitor mimics the substrate shape. It blocks the real substrate from binding to the enzyme, and it binds specifically to the active site of the enzyme. It does not change the shape of the enzyme. A non-competitive inhibitor binds to the allosteric site of the enzyme and does not compete with the substrate for the active site. It also changes the enzyme shape to prevent the substrate from binding to the active site. It is important to note that both inhibitors are reversible, meaning that they stop the enzyme for a specific period of time. Now that we understand the key components, let's look at competitive inhibition. A scientific example of competitive inhibition is methotrexate, which competes with folic acid for the enzyme dihydrofolate reductase. You can think of competitive inhibition as a boxing match, with the substrate and inhibitor competing for the active site of an enzyme. There are two scenarios that can arise from this. In scenario 1, the substrate wins the fight and will bind to the active site. Referring back to our scientific example, this is folic acid, which will bind to dihydrofolate reductase. If this occurs, we will expect DNA synthesis in rapidly dividing cancer cells to be produced. However, in the second scenario, let's say that the inhibitor wins the fight and binds to the active site. Referring back to our scientific example, this is methotrexate. If this occurs, we would expect the blocking of DNA synthesis in rapidly dividing cancer cells. Now, let's look at non-competitive inhibition. A scientific example of non-competitive inhibition are lead ions, which bind to alpha-aminolevulinic acid dehydratase enzyme at the allosteric site, preventing alpha-aminolevulinic acid from binding as the enzyme shape has altered. You can think of non-competitive inhibition as a foot race with two participants, the substrate and the inhibitor. Whichever one crosses the finish line first will bind to the enzyme. There are also two scenarios that can arise from this. In scenario 1, let's say the substrate beats the inhibitor. It will bind to the active site of the enzyme. Referring back to our scientific example, this is alpha-aminolevulinic acid. This will result in an intermediate being formed in the hemoglobin synthesis, which will allow for oxygen to be transported in the blood. Now let's look at scenario 2, where the inhibitor is the one to cross the finish line first. Referring back to our scientific example, this is lead ions. Lead ions inhibit the production of the intermediate in the hemoglobin synthesis. This will result in lead buildup in the blood, producing lead poisoning. So now that we have gone over both mechanisms, let's summarize. Competitive inhibition you can think of as a boxing match, where the substrate and the inhibitor are competing for the active site of an enzyme. In non-competitive inhibition, you can think of it as a foot race, where the first to cross the finish line, either the substrate or the inhibitor, will be the victor and bind to the enzyme. Thank you for watching.